Okay, welcome to my lab on sequential logic. In this design project, the objective is to have a 7-segment display output my student number, which is 400330671. So first we're going to create logic in the analysis section, and then we're going to use multisum to verify that the logic is correct, and then lastly we'll try to create a physical build. So first we can start off here. So we see that I have 3 zeros that repeat, which make it so that I need a 2-digit counter to keep track of which zero it is. And we're also able to remove the first digit, sorry, the most significant bit, because we don't have any number that is greater than 7. So this is the binary representation of my student number that's been simplified. So using the JK excitation table, we can create the truth table for every state of my student number, and then we get these values here, and then we can begin K-mapping. So we use SOP and POS implementation, and the results for that were shown here. So it ends up that the SOP only needs 5 chips, and the POS needs 6, so we end up using the SOP implementation. And this paragraph is just showing how we optimized it. So we can go to multisim and we can start it. And 4, 0, 0, 3, 3, 0, 6, 7, 1, and then it repeats. And it is flickering. I'm not sure why, but when I look at the timing diagram, it does indicate that it's outputting what it should be. And then we can head back here. And we can see in the timing diagram here that it actually is outputting my student number. And now we can move on to the physical build. So this is the physical build. We couldn't get it to work. So the way we went about building it was first we just laid down the VCCs and the grounds, and then here we connected the don't clears and um, the don't presets, and then we just went by setting up one variable at a time. So we just created it like this, and every picture is just going to show like every variable that we added. And then here, this is where we created the display. We made sure that the resistors aren't touching, but we still were not able to get an output for it. And then this is the clock signal. So here's a video of what we do get. Yeah, so we did try to debug it a little bit. We checked if the 7-segment display was working. We just went through to make sure all the LEDs were working, recalibrated the hand tag. We went in, rechecked all the wiring. We did find a few errors in the wiring, but then still didn't fix it. So I think it was likely an error, something wrong with the clock signal or something with the power source, because we weren't getting any output from the 7-segment display. But overall, this lab was interesting and fun to learn about. And of course, digital circuitry has so many aspects in just any engineering application. But for this lab in particular, I think we basically were able to use logic and to turn LEDs on and off. So I think an obvious application of this lab would be you could try to create you would just have a bunch of LEDs and try to create a picture on it or a video, kind of like a very simplified television or some sort of just digital screen. And yeah, that's the end of my report. Thank you.